Good morning, ladies. Excuse me. It is Wednesday, April the 1st, 2020. We are progressing nicely. Hopefully you guys are doing okay. I didn't bring up my notes. One moment. There we go. A couple of people that I have not, that I'm not getting quizzes from or anything. Shaylin, if anybody has seen her or talked to her, please encourage her to reach out. And also Angela, haven't got anything from her. So, if you visit with her, have her reach out to me, because they have several zeros in the grade book, because I haven't seen them. I haven't got their stuff. And they haven't reached out. So kind of, if you talk to them or want to check on them, know their information, please do. So today what we want to do is do 14.4. And so again, we are moving through this chapter well, okay? Kind of, you've seen the week at a glance. Hopefully we will do 14.5 on Friday, and there will, which is volume. And so on Friday, I'll also post a quiz for 14.4, 14.5, so surface area and volume together. And then next week, we will work on reviewing for our first test online. So will be held in my math lab. So make sure that most of you are hooked up to that, so you're doing okay there. So if you have any questions about my math lab, I know it was down a little bit, and again, we'll work with that, but we'll try to go that direction next week. So kind of look towards that. So make sure over the weekend that you've gotten caught up on all the notes from chapter 14, because next week we'll start the review process. Okay, so surface area. So far we've done perimeter of two-dimensional figures, the distance around. We've done surface area. So thinking about a piece of paper, what surface area does it cover? Now we want to move, or what area does it cover? Now we want to move to three-dimensional figures. So for three-dimensional figures, in two-dimensional we called it perimeter. In three-dimensional we moved to surface area. So it's basically the distance around the figure, but these two are comparable. Okay, in two-dimensional it's perimeter, and three-dimensional we refer to it as surface area. So we're still working in square units. So all of your labeling should be square units. So when you go to find the surface area is the sum of the lateral surface areas and the area of the bases. Okay, area of the bases is called the surface area. So surface area can be thought of as the counterpart to perimeter. So basically when we're working with surface area, we look at the figure and we add up the area of all the shapes that make up the figure. So here's two examples. So the first one on the right is just a rectangular prism. So remember our labeling from previously in our chapters. So we have a top and a bottom, we have two sides, and we have a front and a back to this box. And so what we want to do is we want to add up the surface area of that. And so you have two times the area of the top and the bottom, 2 times the area of the sides, and 2 times the area of the front and back. And it's 2 because you have 2 of them. You have a front and a back, you have a side, you have a top and a bottom. So then multiply, and then you're given the surface area. Okay, the next one is a tent. So first of all, when you look at that base on the front of that triangle, notice that the entire base across there is 10. Okay, each piece is 5, but across there is 10. So make sure when you're looking for base, you're using 10. So we need 2 triangles, the front and the back of the tent. We need a bottom of the tent, and then we need the 2 sides of the tent. So my 2 triangles, so we're using the area formula, 1/2 base times height. So 1/2 10 times 12. And then the bottom is 10 times 20. And then the sides, because we need the length of that side, we have to use the Pythagorean theorem to find the length of that side. And so it ends up being 13 inches. So our sides are 13 by 20 rectangles. And we need 2 of those. So some other formulas as we look through here, a cube, remember a cube is special because it has all your sides are squares. It's not a rectangular prism, all the sides are squares. So if it's a cube, it's all the sides are the same. Okay, so your surface area is 6 times c squared. So the area of one square rectangle times 6. Okay, the next one is a right regular pentagonal prism. So remember, regular means all the sides are the same. So when you go to find the surface area, you have the pentagon on the top and the bottom. So you need 2 of those. And then you need the 5 rectangles. So what I did is I tried to make a general statement for you. So remember your pentagon, the formula for your pentagon from section 3, section 2, I don't remember one of those sections, is 1/2 5 SA, so side times the apothem. Apothem, remember, is from the center to the base, basically the height of the triangle that you're creating. So, and then the 5 is coming from the number of sides, and then the 5 rectangles are side times the height. So I kind of tried to make a general formula here. So when you factor out the 2 and the 1/2 go away, and then you factor out an S and a 5, you're left with A plus H. So for any prism from that, okay, for any prism that's right and regular, for any prism, it's the number of sides times S, and S is the length of the side, times A plus H. A is the apothem. So go back and look at the previous section to refresh on the apothem. And then plus H. H is the height of the rectangle, or height of the prism. So height of that rectangle on the side. Okay, moving to the next one, a cylinder. So there's 2 parts to this one. You have your circles, so your circle on the top and the bottom, so 2 of those. And then you have the side, the part of the cylinder that goes around it. So I made sure and separate these because sometimes we'll combine shapes. So think about if we made a silo. A silo would be a cylinder, but then it would have either a cone on top or a half a sphere on top. So sometimes we have to put together shapes. And so I want to make sure, so you have 2 circles, so it's 2 pi r squared, plus your sides is 2 pi r h. So this is your formula for a cylinder. Your pyramid, again, this one gets kind of crazy, but you have to remember basically all it is the area of your base. So area of your base is your 6, it's number of sides, times 1/2. Wait, I'm doing triangles right now. Sorry, my bad. Okay, so your 6 triangles plus the area of your base. Okay, so the area of your base is your 1/2 times 6 times SA. S again is your side, A is your apothem. And then your 6 triangles that go around it, or the number of triangles that go around it. So 6 times 1/2 base times height, or in this case, it's your base is your S. L is your slant height. So L is the height of your triangle. So I kind of tried to write a general one down here. So N is number of sides. And then substitute in. So this is for a pyramid. Okay, for a cone, you have your base and then you have your sides. Okay, the actual cone portion. So your base is your pi r squared because it's just a circle. And then your sides are pi r l. R is your radius. L is your slant height again. Okay, slant height. And then sphere, okay, for the sphere is 4 pi r squared. 4 pi r squared. So if I ask you to find the surface area of an ice cream cone, an ice cream cone means I would want the outside, okay, the outside of the cone. So I would want the pi r l, and then I would want half of a sphere, So I would only do 2 pi r squared. Okay, so kind of knowing how to put those pieces together, because I don't need the circle on the bottom because it's ice cream, okay, and I don't need a full sphere because I just want the roundedness of it. Okay, some examples. Okay, so we have a pyramid here. So for our pyramid, we want the area of the sides plus the area of the base. Okay, so area of the sides is by 4 triangles. So 5 is my slant height here, or the height of that triangle, not the height of the pyramid. Okay, so I have 4 triangles and then 1/2 base times height. And then area of the base, so area of my base is a square. It doesn't look it, but it is a square. And you have 4 times 4. And I forgot a squared right here. So please make sure you add 56 inches squared. Squared. Okay. I cannot add it. Okay, the next one, I drew a really awful picture. Okay. So the Great Pyramid of somewhere, okay, is a right square pyramid. So that means the base is a square with a height of 148 meters. Now, when they mean that height, they mean the height from the central point straight down. Straight down. So that's 148. I kind of tried to draw it there, but may not have been successful. Okay. And a square base with a perimeter of 940 meters. Now, it gives me my perimeter. It doesn't give me my side value. So over on the right-hand side of the picture, if the perimeter is 940, it's a square, so I know it has 4 sides, so I can divide by 4 and know that my sides are 235 meters. So then it also gives the altitude of each triangle face is 189 meters. So that means basically my slant height. So the altitude is coming out of the vertex straight down. So that's my slant height. So I have area of the base, so 232 times 235 times 235. And then my 4 triangles. So 1/2 my base, 235 times 189, which is my slant height. Okay, a cone. So first of all, when you're doing your cone, you want to, your L is your slant height. So here our slant height is 5, but we also need a radius. So to find the radius, we want to use the Pythagorean theorem, and we get A is 3. So our radius is 3. So substitute in. I did leave it in pi here, 24 pi. WebAssign seems to leave their answers in terms of pi. So I kind of left that one there for you. Okay, and then ones you can try. Again, 14.4 is all about surface area, the counterpart to perimeter for 3-dimensional. So if you have any questions, please ask. And Friday we will do 14.5, finish up with a volume, and look at temperature conversions. So if you have any questions, please reach out. Have a good day.